So indeed, it is really a pleasure and honor for all of us to have him here as a resource person in this afternoon session on the last day of this NEP orientation and sensitization course. So uh, I welcome him on on behalf of Dr. Babasaheb Ambedkar Marathwada University, and I would now hand over the session to him. Over to you, sir. By that time, I would request all participants to open their cameras, please. All participants, kindly open the camera. Yes, over to you, sir. Rajesh, sir.
Is my screen is visible?
Yes, sir. Yes.
Putting it to presentation mode.
Your audio is a little low, sir.
Yeah, okay. That I will manage.
Yes.
My PC currently is taking audio low. I'll manage. Now it is in a presentation mode.
Yes, it is in present, but the first slide is missing. It is something that research missed
Yeah,
leads.
that's only should be there. There would be
Okay.
coming something. Okay.
Yes.
Yeah. Fine. I do not have title slide. Don't worry.
Okay.
Anyhow, today the topic which is given to me was research and development. And today what I'm trying to do is basically to understand what kind of research things which we need to do when we are like when a researcher starts, what is that he has to do, how the data is handled, how things are done, in what way. That is what a researcher, that's what the topic which I will be dealing. So before we start into the research, what is important is we look at certain point which basically tells us that what are the things which we need to look at. Okay, so I'll just pause my video because bandwidth is low. Okay, now it's fine. Uh, when we start doing the research, what happens is generally, particularly for kind of a PhD student who enters in, try to enter into the research, generally his ideas are limited to whatever is the guide, the proposed guide is doing in his lab for several years, or whatever the facilities available over there, it gets limited to that. So basically that research doesn't become any important research per se, because that's just to I'm not saying that there are no important works are going around. There are definitely important research works are going around, but at the same time, that does not necessarily mean that whatever is continued is a good only. Many a times that's a compromise on the research topic. Second is we should also not register the research topic. We were trying hard to uh, bring this change that you should register the purpose of research, not the topic. Because once you register the topic, what happens is you continue to do with that. Even when we are having the proposal submitted as a research proposal to funding agencies, yes, our aim and objectives, our hypotheses, null hypothesis, they are there. But then it does not necessarily mean that everything you know already. If you know everything already, then there is no research. So there are likely surprises. There are likely possibilities that whatever you have planned will not happen. Okay. Now, uh, having said that, let's understand what are the things which a researcher need to be ready for. So first is I am trying to speak about the four missed leads, the leads which you could miss if you are not an alert researcher, if you are not a trained researcher, if you are not having idea that what need to look into the research, that is need to be understood. So the first one is okay, why it is not? Yeah, it is changing. First one is serendipity. Serendipity means anything which is you never planned it and it occurs while doing the research suddenly. And that serendipity, if you are able to handle, here is the Professor Fleming who has invented the penicillin. Penicillin was a life-saving drug for uh, this for entire humanity. Now, why penicillin was discovered? Because there were some petri dishes which were not washed, and then they were lying there for quite some time, and there were some growth of the fungus. This was the growth of the fungus which was occurring over there, and he thought that whatever this growth, let's analyze it. If I would have been the lab in charge, I would have said, "Ki, "Arey, arey, petri dish, you have not washed this. Better wash this and clean this and keep it." Now, this serendipity which suddenly occurred, he has a readiness of the mind to accept that there is something happening and which I need to analyze. Now, such serendipities definitely occur into the research, and are we ready for it? So that's the first point which researcher need to. Second is the sharpening of tools. Whatever the skills, whatever the methods, whatever the knowledge base you have, you need to continue to improve around it. If you don't continue to improve around it, you will be able to, like for example, today's world, a researcher must know what is AI and what is machine learning. Okay, because today you cannot get away with this because it's all data driven science which is going around. Not that everything will need that data driven science, but unless you know it, you will not be able to know whether you need it or you don't need it. Okay, so we'll have to update. Long back, there was a updation of the people for using the computer. Now, computer is a very common thing to use by anybody and everybody. But tomorrow, you will be going to handle the big data, which is much more beyond what we know today. So, continual improvement into your skill is an important aspect. Then, next would be, I would say, this is very important when there's a long-term research is going on. And this long-term research actually needs to focus on various observations continuously, even though many times you do not get any breakthrough for sometimes years together, such as astrophysics kind of thing, where generations after generations, there are observations made, there is a data recorded, and based on this data, there will be at some point of time, there would be some new discovery of a planet or something like that. And this requires lot of patience, lot of time to be invested. It has to be studied in the depth. So this is true for any other research. If you want to do the in-depth study, the hurry cannot be used. This is missing the signpost means if you are very hurriedly moving on a road, uh, likely that you will be missing the all signposts which are saying that go slow or whatever the speed limit is. Exactly similar thing can happen in the research. Whatever the best part of the breakthroughs or whatever the uh, possible uh, outcome of the research which would have come, you are likely to miss it if you are in a hurry. The fourth one, according to me, is a piece of a jigsaw puzzle. That means you need to understand where do you actually fit in into entire ecosystem, lateral thinking of the research, whether somebody will be able to use your research, and so and so. And if the dimensions to the research are improved or added, then it becomes actually complicated. So, but even in this complex situation, you should be able to know what is exact your role or role of your research fit into the society, industry, or further researchers to pursue the research on the same thing. Many times we write in our reports, we write in our thesis that the feature scope of the work. But this feature scope of the work is basically, there is some call, let me check whether it is from the organizer. Hello, speaking. Okay, so that was not important. But then this is what is we need to understand. It's actually like the machine which has got a lot of gears or a lot of moving parts, and in each gear or moves in a particular direction with a particular given speed, then only entire machine is going to work. Otherwise, there goes to be a chaos. So you need to understand if you are a part of a machine, you are a machine, or whatever your research is fit in. So this is another aspect of it. So All these leads, if you miss by virtue of not being a preparedness of the mind, by virtue of not being improving on your skill, updating your skill, or by virtue of a hurry, because every 3 months you have to give a report. That does not mean that within that 3 months you have to hurriedly do something. That means whatever you have done in the 3 months, you have to give that report. Or if you don't understand where are you fit in. So if this all is missed, that is what I call the missed lead in the research. Okay. Now, next is next is a uh, very good story. You've already seen now this yellow sticks. So the story behind this is like this, which I'm trying to make a point that there are no real failures in the experimental experiment and the data. You might not achieve whatever you have planned for. That may be true. Like for example, whatever your hypothesis, you might not have planned. Uh, this story is about the 3M company, which has taken a project which they wanted to develop a super glue. That super glue is something which will not be removed easily once it is stick. Will be very very strong bonding, and they started working on it. After consuming all the resources on the project, manpower or whatever the money was given to them, they ultimately has come out with a glue which was easy to remove. It was not like a super glue. So actually the project is failed. That whatever their plan was to generate a super glue was not successful. They actually has landed up in generating a glue which is easy to remove. And they have discarded that project. They thought that this is not important to them now. This is not important to them. So, but then they have not thrown away the data. They have kept the data, and that data they have started using for uh, these yellow sticks. Now, these yellow sticks are now we know that they are very useful things, but then the glue which was required here was easy to remove kind of glue, easy to stick, easy to remove, and that glue came from this failed project. So data did not fail, although the project objectives were not achieved. Most of the time in our cases, we try to bend upon saying that this has reached to the 70%, 80%, or something, some way we want to prove that we have achieved. Let's be honest and let's keep the data. The experiments are never failure. They can be useful some point of time. Okay. Why it is not moving? I'll just share it again because it did not move. Okay. What, what is Sorry for this, but there is something wrong with the sharing. Okay. Uh, Having said that, what kind of attributes a researcher has to have, and then after telling you the story on one experimental, rather a failure project, but a successful experimental data, I'll tell you one more story which was a part of my own research, and this is very important to look at the data. My perspective looking towards the data had changed on that day when this happened to me. Okay, so this is I was working on the hydrogen as a fuel. So look at the hydrogen y-axis, which is the hydrogen production rate at a different time, which is indicated on the x-axis. Now, this is the data which I got in the very first experiment. And what happened was I was doing this at a Hokkaido University, Japan, and my guide wanted. He called me after I went and set up the experimental setup, started working on it. But just one experiment done, and that day he called me and said the funding agency who has funded this was a Denso Motor Corporation. So they are going to be here tomorrow and you need to present your work. I said, there is nothing to present. There is nothing to present because I just have started the experiment and I do not have actually any data with me right now. So he said, whatever it is, but tomorrow is the review meeting and you need to present. So I prepared few slides, some uh, 11, 12 slides I prepared. Just as usual, our researchers will prepare the introduction, 3 slides, and background, 1 slide. So, so a lot of things, then experimental setup detail, and the last slide which was there with this data. Okay. And although while trying into the PowerPoint, these were the peak which are very broad. Actually, they are very sharp peak. All the time it was almost zero hydrogen production rate. Only 3 times it was slightly showing something. Now this data was presented to Denso Motor Corporation, and there were almost like more than 40-45 minutes discussion which went on in Japanese, and I was not getting anything out of it. So I was puzzled and trying to look for what they are discussing on just one set of data and which is not so good. All the time it is zero. So after some time, these people realized that I am not getting what they are discussing in the Japanese. So they started explaining, my professor started explaining me into English. And he said, Denso Motor Corporation people are very, very interested in your data. They are appreciating this data. I said, come on, this is not the data which can be appreciated because all the time we are in the zero. So uh, Denso Motor Corporation explained me that yes, you are right that your hydrogen production rate is almost zero for most of the time, but we are not interested in that. We are interested in this range, which here you are now looking at a green band. So we are interested that hydrogen production rate should be in this range. And in the very first experiment, you have reached there 3 times. Okay. So now the job is try to find out these conditions when this happened that this peak has reached to the desired zone of hydrogen production rate. If you can find that and if you can keep that continuous, we will have a successful experiments. So this is something we are tend to look at the zero kind of thing where the maximum data is zero, but nevertheless there are some data points, at least 3 data points, which were in the region of the interest. So we need to look at the data in that way. So that was a kind of a data perspective as I got it. Now let's come to how do we select the research area? I would not say about the research topic, but the research area, how do we select and how do we work on it? This is for the beginners also. This is for the experienced researchers also. I would suggest, in my opinion, 3 types of priorities can be fixed. One is the need of the local. Local means it could be your own need. Uh, for example, I will give you the one more example over here. Like you must have heard about the Bose speaker. They are the best quality speakers available for any music or audio things. So Bose is was a Indian guy who had a habit of listening to radio, and the radio speakers were not so good. So he always gets to get noise out of it, and no good quality of audio would come. So therefore, he thought that there has to be somebody who is to generate, produce or manufacture something like a good quality of speakers. And then he realized that why somebody else? Why not me? And he started looking for developing a good quality speaker. At the end of the day, today, of course, there are few more companies now who produces good quality of speakers, but the Bose speakers are still the number one in the world, that the best quality of audio they give. So that was his own need, that to remove the noise from the audios which he was listening to. So that could be one of the way of looking at it. It could be your community, your family, your city probably, and a lot of things such as water, health, food. These are some of the areas which can be prioritized. So we need to work on this. And why I'm saying so, why I'm trying to say these priorities is because the point which I missed to tell you is research has to be purposeful and impactful. Please mark these two words. Purposeful, it has to have a purpose. That research has to have a purpose. Otherwise, it's of no use. And it should be impactful. It should make a larger impact, not just a marginal impact. Okay. So this is why we need to set the priorities. Next is national need. Next level, if you move from the local level, you go to the national level. National priorities as on today are water, energy, environment, and there are other more national priorities. Say, for example, if you have heard about the Sustainable Development Goals, I'm sure that slide is not here, but let me check. Let me talk about this right now, but then if slide comes, we will talk on that as well. There are sustainable development goals, 17 sustainable development goals, which most of the countries has agreed, and United Nations has put that into as a charter for all the countries. Now, these 17 goals uh, are different. Like, for example, providing clean water to everybody, providing health. Then it could be something like education. The goal 4 is education. Goal 11 is sustainable cities. So many things are, many goals are there. And on each of these goals, probably we are, as a country, we are not doing good. Okay. Our number is not very high in most of these. So as a researcher, it is our duty as well to find out anything which we can do to improve our ratings on these, because we can provide the technological interventions, we can provide the social interventions, we can provide the market tools for improving this area, to improve these in these areas, and that can happen. Now, this is what we researchers as a should look at the sustainable development goal. Further down the line, on the national level, uh, I would suggest you to go and find out there are a lot of treaties which India is signatory. And these treaties are, say, for example, Minamata Convention. Minamata Convention is for avoiding the use of mercury across the world. Transportation, storage, use, everything to be avoided, because mercury is a kind of a heavy metal pollutant. If it reaches to your body, it it causes damages to your nervous systems, your brains. So this is a very dangerous material as far as things are concerned. Now, once we become a signatory to any treaty, there are national obligations to follow. Say, for example, uh, we will say that we will have a protocol developed for handling whatever the mercury we have as on today, or its disposal, or like, for example, Ayurveda uses parabhasma is one of the things which Ayurveda uses, which is nothing but the ash of the mercury. So in that case, how are we going to handle? What are the protocols we are going to develop? So these are the traditional uses. So whether traditional uses can be continued, all that can come from the as a national obligation. And while fulfilling those national obligations, researchers has role to play. So we can find out what can be contributed by us as a researcher. Then comes the global need. Obviously, you move from local to national, national to global. And in that case, very precisely today, if you talk about the climate change, that is important aspect. Climate change and overall health, one health programs of the country. That is the kind of things which we need to look at the global level. Climate change was a topic of discussions in the academic and scientific forum quite some time, but now it is knocking your doors. You are already seeing the change in the weather patterns because of the climate change, and there is a lot of things which are happening around you, including the monetary loss, because you are getting unexpected urban floods, you are getting uh, drought in some areas where it should not be. So various things which are happening, like for example, Cherrapunji is no more the highest rain receiving area in the country. Okay, there are things which are happening because of this climate change. So priorities which we need to find out for the research, or even the areas for in which we want to do the research, can probably focused by this way. Now, once you have a priority set, there could be choice of the methods, and the choice of the methods is first is I will talk about the Newtonian approach. The Newtonian approach is the reductionist approach. Means you have a bigger problem. you try to break it into smaller problems and try to solve these smaller problems one at a time. And ultimately, uh, the hope is that we will solve the bigger problem together. Just hold on, somebody is calling repeatedly. Let me check. Ah, so that is the Newtonian approach. You break the problem into smaller problem, and then you try to make sure that you solve those small problems, and ultimately assuming that you will get into the bigger problem solution to the bigger problem. But many times this may happen, many times this may not happen, because when you break the smaller problem into smaller thing, actually it loses the connectivity and the complexity of the entire system. Whereas a Darwinian approach is something which currently being handled today, which is more holistic, and it can handle the complexities in the system as it is. Why I'm saying this is handled today, like uh, if you look at the artificial intelligence or the machine learning, is a data-driven science. You have a lot of data, and you'll try to let evolve this data completely, and find out that this data can generate certain relations, cause-effective relations, and other things. Okay. Now, next is why slides are not on. Now, what is purposeful research? I was saying that it has to be purposeful and impactful. So let's talk about the purposeful research. Okay. The first thing which I would like to say is the purpose that is beyond the personal progression. In the sense, sometimes purposes are like just to obtain a degree, or sometimes it's a number of papers to be shown so that some promotion can be obtained. That's I would say not absolutely the use of the research. That's not the purpose of the research. What for you are doing? What are those research then? Bringing value to the society and the nation. If we can bring some value to the society, value to the nation, in terms of anything, in terms of employment generation, in terms of higher education, in terms of easiness of operation of something, mobility, etc. If you're looking at the solutions which are novel, then your research has a purpose. And the novelty I should define here. Novelty has two, three things. One is we call it as the innovations. Innovations are the small changes which are sometimes obvious or which can be commonly said. And these changes, when they are there, they actually mm, they actually are not really the invention, but they are just a small adjustment, small modifications, which will give you certain more functionality to the existing known things. So I call it as a innovations, although they are also important, but sometimes some innovations have a very marginal usefulness. So those are not very really good. You know, when the innovations has to have a slightly larger value addition. Whereas inventions are something which are really novel things. So the novel thing can never happen every time. Most of the time, I have seen that the people asking to the PhD student, "What is novel in your PhD?" Okay, we have written somewhere in the guidelines that it has to be novel, but many times it may not be, because bringing the novelty is not that planned thing which you can do. It will come, you can think over it, you can try doing it, but you may not be successful, you may be successful, both the things can happen. And therefore, the novelty or inventions are not that easy to come. Innovations are possible. Okay. Uh, Either saying that whatever the solution you have brought as your research, either it's an innovation or invention, is it that more efficient, or it is at the same? Because if I try to do certain things differently, but there are already existing solutions which are more efficient, then who is going to look at me? Just not because it's a new solution, somebody is going to look at me. Being efficient, do not make it more effective. Effective is something which is efficient is related to that particular process, that particular thing which is efficiently being done with the rapid space and anything. Effective is the solution on for which the problem for which the solution is being applied, whether it can really solve that problem to the extent that effectiveness need to be understood. Then whatever you are doing, is it more sustainable? Is it sustainable that if you repeat and if you continue to do that, whether it is sustainable financially, whether it is sustainable socially, whether it is sustainable environmentally? All three has to be taken care of. And therefore, what we are talking about is uh, sustainable solutions. Then our last but not the least is, are they economically viable? If they are not economically viable, suppose there was a period where alchemistry was used, alchemist was there. Uh, People were thinking that any metal can be converted to gold. Okay? Um, and a lot of people started working on these ideas to convert uh, metals into gold. Now, that is theoretically maybe possible. You may have a process of converting any metal into the gold by various processes. But if its cost goes 10 times than the current gold cost, what is the use of it? It has no use. So economic, see, technically it is viable, but economically it is failed. So such kind of projects, such kind of research will not see the day of the light. I can generate a very best product to compete somebody, but compete in terms of what? In terms of its functionality, its efficiency, effectiveness, everything is done, but at the end of the day, the cost will matter. So if I am very, very efficient and my cost is just 10% higher, still that can be acceptable into the market, that can be accepted, that can see the day of the light. But if it is 10 times, nobody is going to buy it. Okay. So your research will not solve the purpose. Okay. I am trying to move towards the mission mode projects. Uh, how to make it impactful research? Once you find the purpose, how to make it impactful research, and how the research can make the impact into the areas which you never thought before while doing so. So this is a story regarding man on the moon. Everybody know Neil Armstrong has put a first step on the moon, and this is what is the photograph from him. And there is a buggy which is moving on the moon surface. Now, why I'm telling this story is because basically when this happened, when this Neil Armstrong landed on the moon, before that, about an year before that, uh, Russia started already a program to put a man on the moon. And America and Russia was in a competition, technological competition. So American president called his own agency, his own researchers, and asked him if Russia is trying to put man on moon next year, can we do it before Russia does? So everybody said no, we cannot do, because there are many, many issues. The issue number one, we do not have such a alloy which is lightweight and also will sustain the re-entry of the space vehicle. We do not have the textile to generate the space suits, so and so. So they have listed too many of them. So he said, nothing doing. I want to start the research around it and start solving each problem. So this is kind of a Newtonian approach. You started breaking into small problems and started working on it. So during that period, America has seen development of lot of alloys, light metal alloys, aluminum, hindalium, germanium, this kind of metals came. And a lot of polymer industry also came up that time. With lot of polymers has come. And therefore, there is a lot of polymers has come at that point of time. And they started working on space suit. And therefore, uh, actually, it has resulted into the man on moon mission definitely was successful. At the same time, other mission or other impact was also there of generating a lot of other industries in such as metal alloys, textiles, fuel, many more. Okay? So this is something which is contributed to the economic growth of the country over there. Today, I can give the example of ISRO also, and I don't think where this slide over here, but the ISRO also has done a lot of things like Chandrayaan. Chandrayaan is a mission mode project. So if you take a one mission mode project which has got a big objective and everybody start working on it as a team, and then you realize that at the end of the day, entire team achieves the great thing. So this can happen only when there is a multidisciplinary team which is doing their own job. Say for example, in this the example which I was trying to give, uh, there were some metallurgists which were working on the metal alloys, and there were some textile engineers which were working on the textile. So they were the different people. They don't know each other's area, but then entire thing ultimately was resulting into a one mission successful. So mission mode projects are always good. If you plan a big mission mode project, make a team, big team, where a lot of people from the trans-boundary research, I will call it, because crossing your own boundaries need to be there. So one more thing which can be done is like it's not necessary all the time is applied research, but the purpose can be to understand uh, basic phenomena. Say, for example, in the quantum physics, you try to understand there are various phenomena which is the quantum level, whereas on the biological side, let's understand photosynthesis and try to make artificial photosynthesis. This is something which is very, very important. Uh, I can give an example. Photosynthesis can occur uh, by help of chlorophyll that we all know, and that in the presence of sunlight and some water around. That's what the that can happen only in the leaves, plant leaves. That is what we know about the photosynthesis. Artificial photosynthesis is something different, but there is a this natural photosynthesis by I would say it's an engineered photosynthesis which was done was like there was a paper in the Nature which said that when a frog lays the eggs and the toads are formed, there is a jelly left over there for the survival of these toads. And this jelly is neither a dead thing or not a really living thing. It does not reproduce itself, but it lives there for long, long time. It does not get what is it, deteriorated. So what people have done is, in that paper, it was reported that they have injected chlorophyll into this jelly, and first time ever they reported the photosynthesis by using chlorophyll, natural chlorophyll, outside the leaves of the outside the leaves of the trees. So this is something which is a very fundamental principle applications and understanding the basics and trying to make sure that there would be a game changer which will occur. So basic and general research also can be the purpose, not necessarily always a product of the process. Now, deeper research that is also there, like uh, the example of the ISRO I was trying to give of the Chandrayaan, which is also there. Then the kind of national and the global benefit way we have done the COVID-19 vaccine, which was very much appreciated because that was the need of the day. We might have a lot of question marks around this vaccine as on today. Lot of reports in both the sides are there, but at the same time, it was necessary during that pandemic that lives need to be survived, and therefore this kind of research is important. Now, how not to do the research? Okay, uh, this is something which is I am taken as example, nothing to say something around what there was a lady who was working in our group somewhere, and she wanted my opinion about, she was working on chanting of some mantras and then effect of it on the cancer patients to cure the cancer. I said, you cannot say so because you do not have the data, enough data. If you have enough data, I will believe you. But there is no such direct cause effect relationship data is available, and therefore it cannot be said like that. So the discussion went ahead, and she said, and it has been reported by many people. Here is the report, that report, this report. She has shown me a lot of papers. I said, Suppose if I am chanting something, it generates say dopamine in my mind, which gives me the relaxation, and therefore I am getting help in curing the some disease that can possibly happen, and it can happen by chanting anything. So I just jokingly said her, if probably then if I say start taking Amitabh Bachchan's name several times, because if I like Amitabh Bachchan very much, then probably it will help. And she said, sir, there is a paper. There is a paper of saying that Amitabh Bachchan's name has been taken and cured. Then I said there is no science in this. So you need to have a holistic and realistic approach. Realistic is necessary. It is not that if somebody has reported that means it is true. It is not so. You will have to verify with the data in it. Okay, mission mode project I already talked about, like ISRO's example again. PSLV C-37, when it was launched in February 2017, it actually carried 104 different satellites in a one single go. The rocket has taken the 104 satellites we know, and they were all placed into their respective orbits successfully. Okay? So something which is very, very important, and this is what is the top priority that we should start talking about the mission mode projects. ISRO has, DRDO has a lot of mission mode project, but even at the university level, even at the academic institution level, we should also generate the mission mode project. Our missions could be smaller, not necessarily that bigger, but bigger mission, if you can do it, you can be the part of bigger missions, and that is what is the most desired thing as far as mission mode projects are concerned. One of the problem which I was trying to say is one of the mission mode projects which we can think of across the country is wastewater. You have a lot of wastewater around, and we are not able to solve this wastewater problem. Let's give me some, I'll give you something like some figures. Just look at the domestic wastewater we generate, which is about 72,000 million liters per day. 72,000 million liter per day. Out of which, actually, to the standards, treatment to the standards, after passing through a sewage treatment plant and then releasing it to the atmosphere, is just 12,000 million liters per day, MLD per day. That means almost 60 million liters per day is going to the our water bodies untreated. And then we are saying that we do not have the clean water bodies and we need to have. Now, while looking at a problem, if we want to find the root cause of the problem, I have tried this method, which works very well. This is a 5 whys method. You define a problem and then ask questions like why it is happening, why is that, means why it is happening, you have answer. Then you ask why to that again, then why. So if you ask 5 why, you will reach to the root cause. So this is something which is we should do. These are some of the problems which I was saying, like global level. So this is something global warming. You had some temperatures of 1951 to 60s decade, which are about 0 degrees centigrade. Suppose that the temperature change, which we are looking at, no change at this point of time, to something like 0.82 degrees centigrade higher temperature in by 2020. Now, there was a limit which was fixed that 1.5 degrees centigrade on an average temperature, if we increase, we are going to face a lot of problems. We have already almost consumed more than 1 degree centigrade of it, and we have left with very less choices. We have to worry about the greenhouse gases which are around. So these greenhouse gases are carbon dioxide, which is contributing to 65% from the fossil fuel and industrial processes, whereas carbon dioxide from the forestry and other things are 11%, and whereas other gases, which are methane is 16%, nitrous oxide is 6%, and some other gases is around 2%. Now, why I'm saying is this is one of the areas carbon capture, utilization, and sequestration. We say carbon, but it is basically carbon dioxide or carbon dioxide equivalent for greenhouse gas effect, greenhouse gases. So these greenhouse gases has to be addressed, and we need to look at it because this is a survival reason. If we don't, if we don't stop or if we don't take care of these gases at this point of time, and if we are not able to control the global warming, we are going to face huge difficulties. This year, you must have experienced, those who are in the Delhi or even other part of the country, the summer was very hot. Okay? You had a very hot summer, but at the same time, you received the rains in the summer, which was unusual phenomena. This has started happening last 4 5 years, that you are getting, like where I live in Nagpur, and Nagpur started receiving rains in the month of May. Generally, April and May, you do not receive rains in the Nagpur. But this is something which is a climate change, and therefore these climate change effects are also bringing a lot of bad effects on the agriculture. You know. This is something which actually bringing economic losses also. Okay. So there were a lot of conferences occurring around the world, and people are committing. So COP26 and COP27, we have made some commitments of getting net zero or reducing our carbon emission by 30%, footprint reduction of the carbon, and increasing the green footprint. So these are also the carbon capture, utilization, and sequestration could be the area of the work where you need to focus, you need to find efficient way. This could also be the part of clean energy or renewable energy. When I said renewable energy, suddenly we look at the kind of solar panels. And here I want to make a point that when you are trying to make a solution, you need to worry about not for the today only, for the future also. When solar panels are installed, they are per se are very clean at the generation point, energy generation point, like rooftops. Whereas if you look at the kind of composite nature of the solar panels, then you are seeing all these layers around, which has got a kind of metal sheets, glass sheets, then semiconductor solar cells, then encapsulate again a glass, then tempered glass, and then aluminum frame. Several things are there which are which makes these are the composite material as far as disposal is considered, when it is going to be disposed of after 15 20 years after its useful life. So we are going to generate a certain waste which is highly complex in nature and which we don't know how to handle. Okay, so this is going to lead over there. There are various other ways on means and looking at it whether we can have this complex. One more point I should mention here is all these photovoltaic cells which are made for the solar cell are made out of the fusion processes of the quartz. And these fusion processes are very dirty. Okay. So their manufacturing is not that clean, although they looks to be very clean when they are producing electricity at your rooftop. Okay. From while saying so, what is to be done then? Then you should look for the life cycle assessment. Life cycle assessment is you are starting with the what are the resources which you are using, how the processing is done, what are the energies consumption in the process, what are the resource consumption in the process when you are putting the resources into it, then manufacturing, then distribution, then uses, and end of the life. So cradle to grave analysis of everything. There are systematic methods of doing this kind of analysis on life cycle. And uh, one example here I would like to mention, while selecting some of the solutions, many times we land up in doing some mistakes. When plastic polythene bags were being banned, uh, low density polythene bags were banned, people started preaching that start using paper bags. But if you do the life cycle assessment, paper, and there are reports available in the public domain, you can go and read. The paper bags are more harmful than the plastic bag to the environment when you look at the life cycle assessment approach, cradle to grave approach. So suddenly moving towards paper bag from the plastic bag was a not a good solution. It was not fully understood kind of thing. So the question comes, what is the solution then? Then the solution is reusable, washable cloth bags, which is a rather solution as compared to your paper bags. Uh, Here I'm going to, after this slide, I'm going to tell you about how you pursue one particular type of research in the deeper way by giving the one example of my lab where I was working on certain aspects of hydrogen. And although it is coming from the chemistry, don't worry about it too much about the chemistry. It is more important to understand the process by which this has happened. So this is something, a simple reaction. This is a chemistry reaction, which is where the toluene is hydrogenated. Uh, Toluene plus 1 mole of the toluene plus 3 moles of the hydrogen. And this reaction gives you at something like 200 to 250 degrees centigrade and some pressure of 8 to 10 bar along with a catalyst. It gives you methyl cyclohexane. So this is the reaction which was uh, taught to us, I think somewhere 8th and 9th class. This is the 8th or 9th class textbook reaction. Today, I don't know whether it is still there in those textbooks, but at least at our period, this was there. This reaction is reversible. Okay, this reaction can be reversed by increasing the temperature and lowering the pressure, and then again using some kind of catalyst. So if you take a methyl cyclohexane and the temperature of the dehydrogenation reaction is 300 to 400 degrees centigrade and the pressure is 1 to 2 bar as compared to 8 to 10 bar over here, then this gets split up again. You get toluene and hydrogen back. So this is a very simple reaction. What is important is this reaction is a reversible reaction, and the catalyst, if you choose properly, could be highly selective, meaning to say that this once it break, it will give you hydrogen and toluene back only. There will be no other byproducts which will be formed. And 1 mole of this methyl cyclohexane actually has got 3 moles of hydrogen which can be separated out from here. So having understood with this simple reaction, with this simple advantages of this, what we worked was one catalyst, reactant, reactor, process integration, and its application. So what was generated out of this reaction was a concept for hydrogen storage and supply. Okay, so this is a graph which says on the weight capacity basis, and this is on the volume capacity basis, what is the hydrogen storage could be. There are many methods of hydrogen storage, including modified high pressure tank, ultra high pressure tank, carbon nanotubes, hydrogen storage alloys, which you know as the metal hydrides, those people who have heard of it. So there was a goal set up by Department of Environment USA saying that the 6 weight percent should be achieved and around here 60 kg of hydrogen to be stored per meter cube of storage space. Nobody could achieve it. Therefore, it was downgraded in 2015 and the revised goal was much more lower. Whereas the reaction which I showed you before has a potential as a liquid organic hydride much higher than even the previous goal, which was not downgraded before. So therefore, we started working on this reaction and what we generated was this kind of system. Now we have a technology around this, and this is what the same reaction, hydrogenation reaction occurring at the hydrogen production facility, where you pick up the hydrogen and the methyl cyclohexane has got all properties which is close to petrol, gasoline, and therefore it can be transported using lorry kind of structure. Otherwise, if you want to transport the hydrogen, either you will have to have a very high pressure cylinders or you have to have a cryogenic temperature. Now we can do it at the near ambient condition, ambient pressure, ambient temperature. Once we reach to the point where you have to supply the hydrogen, a reverse reaction can occur, and this hydrogen, which is, since the reaction is very selective, this hydrogen is the purest form, more than 99.99% pure, and therefore this is useful for providing hydrogen to the PEM fuel cell, proton exchange membrane fuel cells, which are very common for generating energy nowadays. And they require a pure hydrogen. This hydrogen can be supplied over there. Best part of this is, since it is going with the lorry kind of structure, you do not need any infrastructure, and this can go to the larger distance. You can store it as many days you want in the methyl cyclohexane. So this can go 200 kilometer, 500 kilometer. In fact, there is experiment being done that hydrogen is produced in Australia and transported to Japan using such kind of method. So this is a long-term hydrogen. Where from it has come? It has come from a very simple textbook chemistry reaction. But if you understand the potential, if you understand what are the feed and the products and the byproducts are there, and how to deal with this reaction if this has generated into kind of a technology. These were some of the efforts which we did during the research. This is what is the prototype level which we are at currently. We are having the one normal meter cube per hour of a hydrogen which we connected to a 1 kilowatt fuel cell stack, and we did a lot of experiments. So this is at the prototype level. This has resulted into there are various patents granted to us. We got an Indian patent granted, US patent granted, European patent granted. In another 7 countries, there is a national filing of this patent. So one simple chemistry reaction, if you pursue deeper and deeper, as I said, we pursued reactants, reaction envelope, then we reactor, then also the process integration, then the application, everything we pursued. We pursued continuously for almost like 12, 15 years, and by virtue of which a simple chemistry reaction has converted into a technology. Ultimate aim for us is to give this the red box which you are seeing over here as our technological product, where hydrogen will come as a liquid organic hydride in lorry kind of structure, and then the hydrogen produced over here by virtue of dehydrogenation reaction will be supplied to the fuel cell vehicles. So this is what is the futuristic plan for us. And okay, having given this example, just I wanted to move towards the national education policy and whatever the research point of view it is written over there. I will not spend much time because I am already reaching to 3:30, to 27, 3:30 to 27 is already there. So what just I wanted to show you that the one which I spoke about the sustainable development goal, these are the sustainable development goals. This is also being spoken into your policy that the education, the quality education is the fourth goal, which is important. So national education policy talks about it. Okay, and I'm not going into this detail, but the action plans. Okay, action plans at the if you look at the national education policy, so create interdisciplinary research capacity at the institute. That is something which is very important. I was talking about the mission mode projects, but the mission mode projects, even if the project is a science and technology project, you kindly include humanities people into that for various socio-cultural aspects, or you include economics people that into that so that economic aspects can also be done. So you can form a lot of groups which are interdisciplinary groups, and their research capacity has to be developed by having their synergistic effect in solving the issues. Uh, Creating the research environment, uh, I would suggest all bachelor's and master degree students to enter into the research. I do not suggest school children to enter into the research. That is not necessary. Rather, that is a waste of the time. Because in the school, you are supposed to learn the subjects. You are supposed to form the basic. Once you have learned the subject, then the research comes. So bachelor's and master's degree student definitely should enter into the research, spend their time into the lab and research, which happens into US, which happens into Europe, which happens into Japan. But in our country, that doesn't happen. Okay, we need to start doing that. Knowledge generation through research papers, book, blogs, videos, after carrying out specific research in area, but not limited to and interdisciplinary. And then, nevertheless, we had a lot of knowledge which was in our country as our whatever people start nowadays is called as the Indian knowledge system. I definitely call it as a Bharatiya knowledge system, and the Bharatiya knowledge system has got many reports. Like one example I will like to give you over here is we are working on wastewater treatment using phytoremediation, and a lot of things which we achieved. We have actually built a lot of plants into the field, but the phytoremediation is well explained into Sanskrit literature, where the species which we are using for this phytoremediation is Canna indica, which is referred as a Meta Tamraraj in a Sanskrit. And exactly the same properties has been explained over there, that it is useful for treatment of the soft waste waters. So there is a lot of literature which we have, and we should look at it. Some other methods can be also used to promote researchers, to award them. That's like a hall of a fame or something like that. While doing the research, it is necessary to interact with the stakeholders. Stakeholders means those who are going to use industries around, local urban bodies, other research organizations, NGOs, etc., etc. I would suggest development of a roadmap for next 20 to 30 years. If you have that roadmap, then probably everybody can contribute to it, and then there could be a possibly very impactful and purposeful research game. Bharatiya knowledge system, I'm not going to speak into the more detail, but I was highly impressed at looking at the IIT Kharagpur and Roorkee about the BKS, which is BKS based research they are doing. BKS is again Bharatiya knowledge system. A few more points to create the R&D environment: inclusion of research and internship into graduation curriculum, faculty career, which is happening now. A lot of we started getting lot of requests for internships. Faculty career management system that gives weightage to the research and the governance, and the regulatory changes that encourage the environment for research. So I will stop by giving some cautions. Create a evaluation and monitoring system. Otherwise, what will happen is you have to differentiate between, as I was telling, that innovation and invention. The innovations could be marginal or limited. Innovations could be substantial and useful. Innovations can be there with the inventive steps also. So there is a gap in between, and then comes the inventions. You have to differentiate your work between in all these four, and as you go towards the invention, it is more important and more impactful. Do not promote anything margin or limited invention. Priority of invention is invention over innovations with inventive step and then substantial invention. Do not push for a quality papers patent, but insist for the quality through peer review internally. Say quality papers, quantity of papers can come, but don't push for the quantity, push for the quality. I know one of the professor which was there in our Japanese lab, he used to write only 2 or 3, at the most 3 papers in a year, along with all his 5-6 students. Why? Because he was always insisting that my paper will be a very quality paper. I don't want large number of papers. I need a quality paper. So quality is rather more important, because quality will give you a lot of citations, and citations for a longer period. That is more important than just having the paper. Having said this, thank you very much. Thank you for giving me this opportunity to speak to you, and thank you for patient listening. If there are any questions, I will be happy to answer those.
थैंक यू सर. सर एक 2 मिनट में आप स्टार्ट करते हैं सर.
Any questions around? I can answer those questions.
Yes, Biniwale sir, we can conclude this session, as you have told that you are preoccupied in the next hour. So just we will have a formal valedictory for 5 minutes, sir. I will take only not more than 5 minutes of yours.
Okay.
Gaurav, you can start the university banner and university song.
गीत आमुचे आकाशाचे,
गीत आमुचे सागराचे, इतिहासाचे जनावनाचे, गीत आमुचे जागराचे, गीत आमुचे आकाशाचे, गीत आमुचे सागराचे, इतिहासाचे जनावनाचे, गीत तंतु तंतु संघर्षाचा पैठणीत भिनलेला.
नक्षीतच पक्षी पक्षी विजयाचा मिळलेला.
सोन पहाट उदयाचे गीत आमुचे उजेडाचे इतिहासाचे जनामनाचे गीत आमुचे जागराचे. प्रज्ञेचा सूर्य नवा शब्द शब्द उजळून गेला. समतेचा संगराचा अर्थ ढाळून गेला. विराट विशाल संस्कृतीचे गीत आमुचे जीवनाचे इतिहासाचे जनामनाचे गीत आमुचे जागराचे. गीत आमुचे आकाशाचे गीत आमुचे सागराचे इतिहासाचे जनामनाचे गीत आमुचे जागराचे.
Thank you, Goro. You can stop the university song. So, on behalf of Malviya Mission Teachers Training Center, Dr. Babasaheb Ambedkar Marathwada University, Chhatrapati Sambhaji Nagar, my special thanks to RB Biniwale sir for sparing his valuable time for this valedictory session and last session of this NEP orientation and sensitization course. Friends, a little request from my side that those who haven't uploaded the documents on MMTTC portal needs to upload that before today. And if some participant failed, their admission will be transferred or cancelled. It was already mentioned in your letters as well. So not taking much of time, I would now request our honorable guest, chief guest of this valedictory function, RB Biniwale sir, to say a few words in the line of valedictory address to this session.
Okay, thank you very much. This is a bit of a formality. I will not repeat anything which I have said before, but that's what the intention research has to be. So I would suggest everybody to contribute in a way that builds the nation. Just in one example which I have not spoken, either it should be the building a nation, or it should be solving some problem, or it should be at least advancement of the science in that area. Like one more story, just a minute or two, I will tell you. When I used to write, I used to collect the data, and then if I want to write a manuscript, I used to go to my professor and showing him the data. He will discuss that data and ask two pertinent questions. One is he will ask whether that data makes any sense. If you say yes or no, whatever, you have to give the reason for it. And once that is justified, that this data makes some sense, there is something which can be brought out from this data, he used to ask the second question. That second question was, will it add to the advancement of science in that area? If you publish this manuscript, will it add to the advancement of science in that area? This advancement of the science is not necessarily science, technology, engineering, but including humanities also, whether it will add some value to in that area. If it is yes, if both the questions are answered affirmatively yes, then only he is used to say, is to allow us to write the manuscript. Otherwise, go back to the laboratory, do more research, come back next week. Okay, come back next year, whatever the time required for the research. So these are the two things which are very important. The first in the session which I said is the purposeful and impactful research. And second is whether your whatever the data or the research you have generated, whether it makes a sense and whether it adds to the value, to the advancement of knowledge of science in that area. If that is happening, then only you should publish. Otherwise, there is no use of such a large number of papers. All that first 2% publishers and all those, they bring you nothing, just the some social media status. I stopped writing papers some 5 years back. I do not write any paper anymore because I understood that if I do in the field, go for the applications, that is more important. And I stopped writing the papers anymore because if unless and until I really have something which is going to result into great science advancement, then only I will write a paper. So I decided it for myself. You can specifically write papers, but unless it is making an impact, I would say consider again. So thank you very much for having me over here. I'm really sorry I could have spoken in a much deeper sense also, but I am involved into evaluation of startup and MSME proposals for Ministry of Mines. That meeting is currently going on since the morning. We have a lot many proposals to evaluate. I have taken a time from that and attended your program. So thank you very much, and my apologies for not giving the specific time to you. Thank you very much.
No issue, sir. Indeed, your valuable time, which whatever you have spared for us, it was really fruitful to all participants. We are really thankful, sir. On behalf of this entire group, my special thanks to you. So a little regret from the director side that he is currently on the way from Pune to Chhatrapati Sambhajinagar, so he would not be able to join this valedictory session. So I think this opportunity to conclude this course with a brief of thanks to all participants and especially to the chief guest of this valedictory function. And before concluding the session, I would request our office, Gaurav Jadhav, to start the national anthem, and I would now request all participants to stand up for national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you, Gaurav. You can end this cloud meeting now.